Picture this. You've crafted a sleek automation script, ready to conquer your testing tasks. You hit run, anticipation builds, and then, bam! The dreaded NoSuchElement exception rears its ugly head. This exception, a frequent hurdle in the realm of automation, signals a simple yet critical issue. Your script couldn't locate an element on the web page. No such element. Exceptions are more than just error messages. They represent a breakdown in communication between your automation script and the application under test. When your script tries to interact with an element that isn't present or accessible, the result is a jarring halt to your automated workflow. Understanding the why and how of these exceptions is crucial for building robust and reliable automation solutions. This exception isn't merely a nuisance, it's a roadblock to efficient and effective automation. Imagine a script designed to test an e-commerce checkout process. If it stumbles upon a NoSuchElement exception while trying to locate the Add to Cart button, the entire testing flow grinds to a halt. The impact is clear delayed testing cycles, missed bugs, and frustrated developers. No such element. Exceptions often arise when our automation scripts and the applications we're testing fall out of sync. One common culprit is timing issues. Web pages are dynamic. Elements load, disappear, and reappear based on user interactions and network conditions. If our script tries to interact with an element before it's fully loaded, a NoSuchElement exception is the inevitable outcome. Another common pitfall lies in the realm of dynamic content. Many modern web applications utilize JavaScript to generate and manipulate elements on the fly. This dynamic nature can trip up our automation scripts if they're not equipped to handle such scenarios. Incorrect locators represent another frequent stumbling block. Locators are the addresses we use to pinpoint elements on a web page. A slight typo, an outdated ID, or an XPath expression that no longer matches the page structure can all lead to our script searching for elements that are, for all intents and purposes, invisible. So, how do we navigate this minefield of potential NoSuchElement exceptions? The first line of defense lies in implementing robust waiting mechanisms. Rather than instructing our scripts to blindly charge ahead, we can introduce pauses or waits that allow the application to catch up. Implicit waits, for instance, instruct our automation framework to continuously poll the DOM for a specified duration, waiting for an element to appear before attempting any interaction. Explicit waits provide more fine-grained control, allowing us to wait for specific conditions to be met, such as an element becoming visible or clickable, before proceeding. Beyond waits, ensuring the accuracy of our locators is paramount. Employing unique and stable IDs, utilizing relative XPath expressions to navigate the page structure, and leveraging CSS selectors for their flexibility can all contribute to more resilient element identification. In cases where dynamic content reigns supreme, we might need to get creative. Waiting for a specific element to disappear before interacting with another, or using JavaScript snippets to directly manipulate the DOM, can help us circumvent challenges posed by ever-changing page structures. While preventing no such element exceptions is ideal, the reality is that they are sometimes unavoidable. This is where the art of exception handling comes into play. Exception handling is about gracefully managing unexpected events, ensuring our scripts don't crash and burn at the first sign of trouble. By implementing try-catch blocks, we can anticipate potential exceptions and define specific actions to take should they occur. For instance, if our script encounters a NoSuchElement exception, while attempting to click a button, we might choose to log the error, take a screenshot for debugging purposes, or retry the operation a certain number of times before ultimately failing gracefully. Mastering exception handling is crucial for building robust and reliable automation solutions. It allows our scripts to gracefully navigate unexpected situations, providing valuable insights into potential issues, and ensuring that our testing efforts continue uninterrupted. Remember, the goal is not just to automate tasks, but to do so in a way that is both efficient and resilient.